Okay, welcome back, everybody. Second day, very rich program. So the first talk is by Cassidy Sugimoto from the Georgia Institute of Technology. She's been working on so many topics related to scientometric, and she's also a co-author, I take it, with Vincent Larivière, of measuring research, what everyone needs to know. And since everyone needs to know what's in there, so this is going straight to my reading list. So anyway, the floor is yours.
Thank you so much. It is a delight to be here today and to have this opportunity for dialogue between philosophers of science and scientometricians. The topic today is focusing really on that dialogue and trying to create sort of a shared space where we can meet together. I will give my apologies that this talk is very raw and chaotic. Usually my talks are very empirical and they're very well anchored. These are really my thoughts of where we're going, and I want to make sure that it's evocative, that it produces dialogue. I want to learn from your expertise throughout this. So also in creating in sort of situating the past, I'm going to fall prey to all of the dangers of cartography. There's going to be a lot of dimension reduction here. And so we're going to go quickly through at a bird's eye view of things, and you're going to be horrified at what I miss and what I don't say. I'm going to populate different little great men theories along the way, which has its own set of issues. There's going to be lots of variability in the granularity. I'm going to spend a lot of time talking about science of science because that's what I know the most. And I'm going to spend the least time talking about philosophy of science, which most of you know the most. And then there's all of the myopicisms that come into this. So you'll see a lot of space where I'm going to lean into certain areas and pull back from certain areas. This is not meant to be comprehensive. Again, this is meant to be illustrative and evocative. So I'm going to focus on key meta-sciences here: the economics of science, the science of science, sociology of science, history of science, and philosophy of science. And I provided a very brief definition that you can find for each of these. And I'm going to go through them, but for sort of a meta point here. If we look at the economics of science, they say it's the impact of science on technology, scientific behavior, efficiency of scientific institutions and markets. But then you go to sociology of science, which is social conditions and effects of science, social structures and processes of scientific activities. And I hope what you already see is the connections of there. Well, what is scientific behavior if not sociology of science? How do you do one without the other? Philosophy of science, what qualifies as science, reliability of scientific theories, and functions of science. Well, how can you study any of the other sciences without knowing that? History of science, the emergence and development of systematic knowledge, and then science of science, the empirical study of science and scientific activities, as if the others are not they themselves empirical as well. So throughout all of these things, what I want to do is say, what are the useful demarcations of this knowledge? Where does it actually make sense to create an epistemological distinction between one meta-science and the other? And where are these not helpful demarcations, where actually there's more shared than there is differentiating them? Now, you may be asking, did you put that on a map of Game of Thrones? The answer would be yes. Did you put the economics of science north of the wall? The answer would also be yes. But we can get to all of that later. So let's try our bird's eye view across each of these things. All right, so philosophy of science, we'll start here, right? You want to start with Socrates and Plato and Aristotle, who have already been mentioned in this workshop, I'll say. But what I think is the key thing that I want to pull out here is what constitutes knowledge. How do you distinguish between knowledge and beliefs, justified beliefs and true beliefs? And you see a lot of that coming out of this work, really the birth of epistemology coming here. And I would argue that you cannot do any of the meta-sciences without being able to answer that question. Whether you're taking it from a philosophical lens or what scientometricians do all the time is try to demarcate a discipline. If you're going to study, say, economics, you have to decide what constitutes economics. Is it a grouping of journals, people, institutions, topics, keywords, right? In each of our choices, anytime we do a study from the quantitative perspective of science, we're demarcating what constitutes a space of knowledge, a space of science. We're trying to define all of those things. So without any understanding of epistemology, one cannot do that. We also start to get into then Bacon, which I put by all their birth dates instead of work dates. And we say science must also be known by its works. It is by the witness of works rather than by logic or even by observation that truth is revealed and established. And that's a really interesting space because many of the early philosophers actually didn't write anything down, but had oral traditions. So now making sure that it is manifest. For something to be science, now it has to be documented, it has to be recorded, is a really interesting proposition, and one that scientometricians rely on heavily, right? Science exists once it becomes manifest in a form that we can mine, that we can assign metadata to. So even these early sort of senses of what constitutes it comes in. Then you have John Locke's essay on human understanding, which to me is the one situating scientists in the making of science, right? Which really gives birth to all of the sociology of science. What does it mean for man to know, right? That is the fundamental question that's a part of that. We've heard about Popper yesterday too, about reproducibility. Now we're starting to think about falsifiability, about consensus building, about how we make science through all of these people doing their scientific work, and then to Thomas Kuhn, where we think about these structural pieces of it, the structure of scientific revolutions, and how we sort of create a canon and then disrupt that canon. We talked about disruption yesterday too. So in all of these things, you start to see themes that permeate across all of the different meta sciences as spaces to understand. So epistemology, of course, is one of them. Einstein famously said that there's a reciprocal relationship between epistemology and science, that they are dependent upon one another. And epistemology without contact with science becomes an empty scheme, and science without epistemology, insofar as it's thinkable at all, is primitive and muddled. You also get the general sense of social responsibility that comes through all of the philosophy of science, goes through Marx. We see this in practice as well. He says the philosophers have only interpreted the world. The point, however, is to change it. So that relationship between science and society, between advocacy, between social responsibility. We have the deputy chairman of the State Committee of the USSR Council on Ministers use of atomic energy, saying a scientist can never be a pure mathematician, biophysicist, sociologist, for he cannot remain indifferent to the fruits of his work, to whether they will be useful or harmful to mankind. And this starts to play into some of our notions around sociology of science, but also to science policy. What is our responsibility as scientists to understand the implications of our work? So in reaching through all of these fields, what I've done is also trying to find texts where people said, here are our key questions, or here is our agenda moving forward. And in one of them for philosophy of science, the key questions were thus: demarcation, explanation, and justification. And what strikes me here is how relevant each of these are for some of the key questions that we're asking today. When we think about what constitutes science, knowledge, truth, and issues of falsifiability, there are many conversations about indigenous knowledge happening around the world. Is indigenous knowledge science? Should it be funded by federal agencies? How should it be incorporated into the canon or not? When we think about notions of explanation, of explanatory power, prediction, deduction, and scientific method, we get really close to all of our conversations on artificial intelligence. Should AI be making science and making decisions? Is prediction useful or good? What are the consequences of that? And inductive reasons, probability, and values, we're also getting into many of those same ethical conversations about how we do science and what justifies the science we do. So moving to history of science, we have a different kind of story, but again, I want to sort of get these pockets for us to create themes together. So many times we anchored this in Jean Etienne's Monteluca, which was a history of mathematics. And what many of the history of science documents and treaties were at the time was a cataloging of previous works. And so there was a cataloging of scientific works, geometry, algebra, trying to say this is the state of what we know. You have Johann Beckmann who coins the term technology, and we start thinking about science and technology as intractable together. William Whewell comes and says, we need a name for those people who do science. Let's call it a scientist, right? I think it's interesting that he says, I should incline to call him a scientist because he was actually writing about Mary Somerville's work, which was one of the first female mathematicians. But that is neither here nor there. We have Sarton comes around, which is really an interesting thing about the institutionalization of the history of science, because Sarton starts to say, all right, men of science make mistakes of every kind. And their knowledge is only improved because they do it together, because they're reflecting, they're documenting, they're interacting, they're in dialogue with one another. And he put a lot of his work both into doing history of science, but also creating a community around history of science, creating journals and other spaces for people to come together. Butterfield is actually sort of speaking like a sociologist. He comes and says, if history can do anything, it's to remind us that all our judgments are merely relative to time and circumstance. And so we start moving into this notion of sort of constructivist stance and social stances on it. Then we have Jorge, who comes in with the normal and the pathological to start thinking about madness, about things that don't follow reason and logic, and how we move those in. Now, he was the advisor for Foucault on his history of madness, and so really brought that notion into it and influenced a lot of Foucault's work, which influences a lot of what we see in scientometrics. And you have Donna Haraway coming in, who's starting to think from a feminist perspective, trying to understand all of these sort of more radical and non-conformative views in the history of science. Key questions from Daston, and again, I think it's really important to try to think through how all of these go together. She said the key question for history of science is what counts as knowledge in a given epoch and culture and why? It's the same fundamental question of demarcation, except now she's situating it within culture, time, and space. How do classifications and hierarchies among kinds of knowledge reshuffle? Yesterday, we talked a little bit about interdisciplinarity as well in here, but this is really still a demarcation question. And how do new ways of knowing emerge? And how are they braided together with older methods into a stronger rope of inference? Now we're getting into prediction again, and those same notions. How do we know what we know? How will we know what we know in the future, and how do we constitute what means of knowing? The key agenda also, though, adds to that materiality and embodiment, right? Thinking about the material culture, the tactical, trying to understand those spaces and how we interact in those spaces. Interaction with craft, experimentation, which I think goes back to some of those indigenous knowledge questions that we had before. All right, so now we're moving to sociology of science, which we already saw the threads of, right? If we move from the philosophy to the history of science, you start seeing sociology of science emerging out of those central conversations happening near the 1900s in history of science. So Fleck, which we mentioned yesterday as well, so you see all of these coming in, says the individual within the collective is never or hardly ever conscious of the prevailing thought style, which almost always exerts an absolutely compulsive force upon his thinking and with which it is not possible to be at variance. Right, so that takes some of those earlier things of we're embedded in time and space and becomes really much more palpable in that. And we have Merton, who comes along, who we think of as sort of one of the fathers of sociology of science, but his first work was very fundamentally a history of science work, science, technology, and society in the 17th century England. We know him more for his book on work on sociology of science, which among other things introduced the notion of the Matthew effect. Now, I put Matthew effects here, and I think it's interesting. I think Yves mentions Schrodinger, how we didn't reintroduce Schrodinger every time yesterday, but we have with the Matthew effect. We had the Matthew effect, then we had Price with cumulative advantage, then we had Allison with reinforcement, we had Teg with success breeds success, we had Barabasi with preferential attention, Newman with their power laws, and there are a host of others. I think there's something like 17 different terminologies that we have for what constitutes a Matthew effect, right? And so we have this space in which all of these different fields and spaces have come together to fundamentally reintroduce the same theory. I will take a quick moment to say that Merton acknowledged in a footnote in 1973 that it is belatedly evident to him that he drew upon the interview and other materials of Zuckerman to such an extent that clearly the paper should have been under joint authorship. He goes on to say, a sufficient sense of distributive and cumulative justice requires one to recognize that to write a scientific or scholarly paper is not necessarily sufficient for designating oneself as its sole author. So what to put out, I think his Matthew Effect paper has more citations total than all of Harriet Zuckerman's work combined. So his nice little 1973 apology is warranted. So then we go from Merton and we go from a more structural sociology of knowledge into Bordeaux. And what we have here is habitus, field, capital, agent. We start situating these things, understanding where people are coming from, how notions of capital reinforce what we do, how we're situated in these fields. Now, of course, going back to philosophy of science, Aristotle also talked about habitus, right? This is something that we've seen pervasive across all of the meta-sciences as well. Now, Jonathan and Stephen Cole come back with a social structural sort of perspective, but they start to think about all of these hierarchies. How do we have hierarchies in knowledge? Now, as you've said yesterday, hierarchies are an organic thing, right? We have rankings and hierarchies, those space, but they started to call attention to them, to document them. Then Norkstina comes and says, well, information produced by science is the product of scientific work. And we need to actually understand how that work is done, how the labor is done, which is a really interesting sort of counter intention to that first philosophical work of saying, well, we know science by the work that it is done, right? So that tension between what constitutes scientific labor, what part of that should and can be measured. Latour goes into the lab to try to understand that labor more. And then just like Haraway, we start to think about more feminist approaches to it, trying to understand alternative ways to knowing and to being known. Key questions here, I drew both from 75 and 88, when both Ben David and Sullivan, as well as Zuckerman, stated these questions. How did the unique tradition of modern science emerge and become institutionalized? Well, that sounds a lot like history of science to me, right? How is it maintained and controlled? How is it organized? What determines its changes and how are they related to research? And Zuckerman simply said it's social and cognitive organization of the work, sociology of it, knowledge, and connections between science and its social context. So again, we're starting to see a lot of these same thematic things running throughout it. Then we go to economics of science, brief history. We're almost done here, and then we'll sort of bring it all together. So people often talk about the canonical work as Science and the Endless Frontier by Vannevar Bush. What I think is interesting, and many people don't know, is that this was actually called for by Franklin D. Roosevelt. He wrote a letter to Vannevar Bush while he was at the Office of Scientific Research and Development, and he said, I want recommendations on the following 4 major points. The first was basically, we've done a lot during the war in science. How do we keep up that momentum for defense? The second was about diseases. How do we basically pull all of that we've done in the war and apply it to diseases in that space? And then the third was private and public enterprises. How do we make sure that we're doing stuff both in the industrial sector as well as the academic sector? And then fourth, how can we be effective in pulling from the talent in the US? And it was actually Roosevelt who said the new frontiers of the mind are before us. And so that is what he drew upon when he responded to this. Now, his short answer, Bush's, said progress in the war against disease depends upon a flow of new scientific knowledge. New products, industries, jobs require continuous additions to knowledge, application of that knowledge, practical purposes. Defense, again, was new knowledge. So the essential new knowledge can only be obtained through basic scientific research. And that became part of the premise, is that we cannot focus merely on applied research to solve our problems, but we need basic research. Now, we have King, who comes around after that and says, okay, the direct contact and exchange between both individual scientists and society grows, but what we need is funding from the national government. And in the United States, the National Science Foundation was founded a few years after these treaties came out to provide that national funding for basic science itself. Now, what was interesting about that is that turn to federal funding, at least in the United States, goes to what Arrow talks about as knowledge as a public good, right? We start to think about knowledge that is something that should be shared openly and widely, and that is not depleted when it is shared openly and widely. So federal funding for knowledge generation, particularly basic knowledge generation, was something that should be shared with the public. But then we start to get into notions of intellectual property, which come in contest with that. So we have Dasgupta coming in and talking about priority creating a privately owned asset, a form of intellectual property, and that we need to think about that space, that tension between what constitutes intellectual property and what is a public good of knowledge. We have institutes and organizations like RAND that come around, and they say the purpose is to promote scientific, educational, and charitable purposes for all the public welfare and security. So we start getting notions of security inching into sort of why we constitute knowledge. We have Stephen and Aaron Berg who start to say, wow, science is increasingly expensive. It is very, very expensive, and we need to think about the optimization of the funding of science and how we resource it. And Audresh, who comes in to start saying, well, it's also about innovation. How can we be more entrepreneurial in the science we create? And Donna Ginther and others saying, also, we have to think about the unequal distribution of those resources and rewards across science. How is capital coming back into it? So you see a lot of those issues coming up from sociology of science also playing in as well. So the economics of science key questions that Stephen did: risk aversion on funding agencies. Do we have too many scientists or not enough? How are we producing scientists? Do we consider diversity? What's the fragmentation of knowledge that happens? How do scientific outcomes relate to government and philanthropic organizations? How do we organize science? If you remember, that was a fundamental question before. What is the entrepreneurial behavior and how does it relate to international trade? So I hope through that brief space of all of those, we start to create these threads. What is common among all of these? What is different? What needs to be demarcated? And then we'll go into the science of science as how it's been construed. And as I said, we're going to spend a little bit more time here because it's many of the people in the room and my own background. So Bernal is one of the sort of first texts that we see in here. And I don't know if any of you have taken the time to look at just the table of contents for Bernal, which is really fascinating. Here's what we cover: what science does, the history, organization, education, efficiency, application, and war, and what science could do: training, reorganization, communication, finance, strategy, service of man, social transformation, and social function. So pretty much it's everything, right? And I think that that's really fascinating because too often we think of science or scientometricians as being in this one thing, but the birth of it, the social function of science, is really encompassing all of the spaces from history to sociology to economics to science of science. Similarly, we have Derek de Solla Price, which is often cited as another sort of fundamental man of science. And he said, it's the examinations of science with the methods of science itself. So maybe that's the epistemological definition. You think, okay, great. It really is. It has to be the empirical space, the methodological space that's going to demarcate science of science. But he goes on to say, the peculiar English usage of the term science acts as a barrier to the belief that subjects other than physics, chemistry, and biology can be scientific. Certainly in other languages, the words Noca and Wissenschaft carry a breadth of totality of learning. He said we could actually call this history, philosophy, sociology, psychology, economics, political science, and operations research of science, technology, and medicine. But we prefer to call it science of science because then it's a constant reminder that it must run the entire gamut of meanings in both contexts. So when he was thinking of this, he wasn't thinking of physics of science, right? He was thinking of it encompassing that broad space that Bernal was also speaking to. Now, we most say we should turn the tools of science upon itself. Why not measure, generalize, make hypotheses, and derive conclusions back to that justification, that explanation? And his approach will be to deal statistically and in a not very mathematical fashion with the general problems of the shape and size of science and the ground rules governing science and behavior in science at large. Now, that may be one of the demarcation points, right? The space that we were looking for universal laws, universal principles that govern all of science, something that not necessarily really was an operational space for the historians or sociologists of science, but that's quite arguable. So a few of those types of laws, just to give a flavor, Lotka's law, which all the scientometricians in this room will know, which was his goal to determine the part which men of different caliber contribute to the progress of science, and the very deep tie to eugenics of early statistics and science of science is certainly observed here. You have Cattell, who did this actually 20 years before Lotka's law, of actually doing a statistical study of American men of science, right? Distributing them across different kinds of institution. The goal of which is to retain the best men, which is a very important goal. But we see that kind of space in our current science of science studies as well. A space by Clauset and Larimore really trying to look at the hierarchy and dynamics in the US hiring and faculty, showing that about 80% of all of the scientists working in tenure track positions are coming from about 20% of the institutions, right? So we're seeing these same kinds of spaces that we observed in 1906. We're seeing the same distribution of people across spaces. We have Bradford's law, again, looking at skewness, but now across journals instead of individuals. And we have Zipf laws, which look at the same thing, but against words. Now, many of you may know this, particularly scientometricians, but how Zipf came up with his law is he actually took James Joyce's Ulysses and he counted the words in it, the, one, two, three, and did that manually. And now we can do that in, about, a nanosecond. And we find that the same laws pretty much still stay in space and are constant. Now, all of these are really talking to skewness as being a universal statistical property of science, which governs the way we think about science and distribution. Now, I think this is really interesting when we start thinking about distributive justice, when we start thinking about diversity, equity, and inclusion spaces. If we understand skewness as a universal property in science, is that normatively good or bad? How should we be distributing resources? How should knowledge be distributed across the world? Are very interesting questions that I think are fundamentally philosophical and sociological in nature. Now we have Eugene Garfield coming in and saying, all right, inspired by Shep's citation index, I'm going to create a science citation index. This was actually funded by the National Science Foundation and NIH in a joint funding. They gave him $400,000 and he launched the Genetic Citation Index in 1964 based on Bradford's Law, the idea to really be more efficient and optimize searching for scientific information. So he created this tool, this standard. And as we talked about yesterday, it's the metadata that we're working with, right? We are constrained by the metadata and the organization of that metadata, which I think is a really important thing as we think about how we move forward. Now, at around the same time, this was 61 and 63, we have other kinds of standards and manuals that come out. All of the manuals, the Oslo manuals, the OECD patent statistics manuals, all of those things are a way that we start to codify knowledge, in which we start to state what are the types of metadata, what are the types of variables that we can use in this space, and those govern the kinds of questions that we can ask. We also start to see a blending in science of science into science policy work. So 3 years later, SPRU was founded by Freeman, the University of Sussex. A couple of years after that, research policy comes along. Now, its little subline is policy, management, and economic studies of science, technology, and innovation. But if you look at the agenda, the mission statement for SPRU in 2021, it's science, politics, and decision-making. It's energy, it's sustainable development, it's economics and innovation, and project management. So you see this sort of shifting and blending across all of these different spaces and fields. That was 66. In the same year, we get Nalimov and Rodchenko, who really coined the term that becomes scientometrics, narcometria. Now, this again is so fascinating thinking back to Bernal. If you look at their models of scientometrics that they propose, this is the list. We need to look at the informational, the flow of knowledge, the logical, the development of ideas, the methodological, modes of inquiry, the economic, the political, the sociological, the demographic, the psychological, and the systems. Again, just like Bernal, it's encompassing all of those spaces. There was not a sense that this had to be demarcated. The one who was looking at the economic could also not look at the sociological, or the one looking at the sociological could also not be looking at the logical, but rather that all of these things were deeply interwoven and intertwined, right? That these are fundamental questions that are dependent upon one another in order to be comprehensively addressed. Now, in 1972, the United States starts to get our science and engineering indicators, a report of the nation to show where we are in science, heavily dependent upon the infrastructures, the metadata, the documentation that we've collected before. We have Francis Nairn at CHI and other places that come up to start to measure this R&D activity as performance, right? In the same way that economic indicators are used to assess nation and corporate economic performance. Now, what's interesting is 72 is the same year that we get our journal citation reports and the JIF, another manifestation of this kind of indicator. Now, Garfield was very particular about how he stated this should be used, right? He said the use of JCR can be of far-ranging significance in science planning, evaluation, its sociology, its history. Citation analysis can be used to identify and map research fronts, to define disciplines and emerging specialties, to determine interdisciplinary or multidisciplinary character and impact of research programs and projects. Which goes to what Yves said yesterday about cartography, right? About mapping, about giving us the space, about Chaumet looking at the visual space of this, right? Not to do evaluative alone, but really to do something bigger as a tool. And he talked about sort of the data from which it's been extracted, which I think is an interesting point. 6 years later, we get the Journal of Scientometrics, the establishment of the Information Science Scientometric Research Unit, the Library of the Hungarian Academy of Science, using that term Scientometrica. Now, what's interesting too, the byline of Scientometrics, an international journal for all quantitative aspects of communication in science and science policy, right? Really situating in that space of science communication, science policy, which I think is quite a different kind of space that most people consider it in. Now we start really moving into evaluative scientometrics in the 1980s. We see Irvine and Martine thinking about foresight in science. How do we pick the winners? Yesterday, someone said, how do we do, can we identify a Nobel Prize winner? Should we do that is an open question. But what's really interesting, and comes to some of our country discussions yesterday, is in '85, the House of Representatives Committee on Science and Technology undertook a science policy study. And it asked the Office of Technology Assessment to examine whether decision-making would be improved through the use of quantitative mechanisms associated with the concept of investment. And the OTA concluded that while there are some quantitative techniques that may be of use to Congress in evaluating specific areas of research, basic science is not amenable to the type of economic analyses that might be used for applied research or product development. So it's not just the arts and humanities. The US felt that basic science also could not be evaluated in that way. And the director, Gibbon, said much of the vitality of the American research system lies in its complex and pluralistic nature. Scientists, citizens, administrators, and members of Congress all play various roles leading to final decisions on funding. While there may be ways to improve the overall process, reliance on economic quantitative methods is not promising. Expert analysis, openness, experience, and considered judgment are better tools. Well, not everyone across the world felt that way. So by 1986, we get the RAE, the Research Assessment Exercise, which has had some new names, and I think what we proposed abolishing yesterday, which comes in and really starts going heavy, leaning into the quantitative use of indicators in order to judge science, scientists, and scientific institutions. And then we start seeing a proliferation of rankings. 2003, we have Shanghai, then Times Higher Education, then QS, then Lighting, then SciMego, then Nature Index, and they keep coming and coming and coming, more and more indicators in order to judge and rank and evaluate and distribute resources. We go down to the individual level. Let's have the H index. Let's move things out. So we go from this macro and institutional down to the micro level. But in order to do that, we're going to need lots of data. So we have the proliferation of data sources coming out of all of these different places, promising you better data in order to evaluate your individual scientists and scientific institutions. So a few years ago, we have Science of Science come out with its key questions, another documentation of the questions that we have here. And they put them in these spaces: the structural, the procedural, the methodological, the social, and the practical. And I hope that what you see by now is that all of these key questions, all of these agenda are fundamentally the same, right? We're fundamentally trying to answer the same thing with these different methodological and epistemological approaches. So I've tried to bring them together here to just briefly pull out all of those spaces. And what I wish here is that I didn't have a PowerPoint, but rather a whiteboard, because I'd like to erase all of these and write them all collectively with you, because I think that we could all come up with a better thing. What are the key questions of philosophy, history, sociology, economics, and science of science? And what is unique? What are spaces that can only be answered using the methodological and epistemological framework of one of these? And what are questions that fundamentally must be answered with a combined or triangulated approach? So we'll come back to that hopefully at the end, and I'm making sure to leave time for it. So a few sort of spaces on imagining the future before we go on. First is that the triangulation of theories, methods, and data across the metasciences is necessary, I think critical to advance science. I think we have to think about all of these spaces, the overlaps between each of these, the uniqueness of them too, what they offer that no other metascience can offer, but where we would be stronger together. And in many ways, this is a multiplication of Snow's two cultures, right? It's not just two cultures of knowledge, but it's in the integration of multiple spaces and triangulation. And I say with a care towards epistemic inequity. And this is a really important part for me, that we should not create a sort of hierarchy of these disciplines in which one is prioritized among others. And I think we see this a lot right now. Most of the capital that we have in science is allocated to those with a specific methodological or epistemological bent. One cannot publish in Science or Nature without a certain type of method, right? And that methodology is not distributed equally across all of these metasciences. So when we think about that epistemic inequity, it is what becomes subservient to another. Are we really raising up each of the ways of knowing in similar ways in order to ensure that we're getting the best science and that that science is being communicated? Now, I do think that bibliometric data can indicate some degree of science engagement and contributions to society, which was a question yesterday. But I think that there are spaces in which we can start to answer social questions with bibliometric data. And we've done that to some degree in our macro level studies of disparities, where we've looked at global gender disparities, where we've looked at racial disparities within the US. We've also looked at that in terms of sort of helicopter science, colonial science, where we look at global funding dependencies across the world. Bibliometric data can tell us that. It can look at who are the authors, who is funding, where is the science located and situated, so we can start to understand inequities on a global scale as well. Yesterday, we referenced some of the language distinctions. These are the languages of the indexed science, right, where we're going increasingly towards English at the expense of all other languages. Now, of course, there's an indexation issue, which we should talk about as well, but in indexation, we make something palpable and measurable. We therefore give it more credibility. So we start to see this kind of shift there. Bibliometric data can inform us on that and help us to make more priorities and agenda setting around how we fund and reinforce and incentivize science. Now, in doing all of this, we need to make sure that any indicators we create, which we talked about yesterday, should be informed by, but not replace values. Now, I know this audience knows it, so I'll go over it quickly. But what we tell all of our students in bibliometrics, right? An indicator is a measure of a concept. And in research evaluation, that concept should represent your values. And now maybe your values are interdisciplinarity or diversity or collaboration or social impact. Any of those things are fine, but those indicators should provide evidence of those values and not replace them. So citations, H indices, GIFs, altmetrics are merely indicators, right? They're indicators of those things. They're not a replacement for the values. They should not become the goal in themselves. And if used reasonably, they can motivate future decisions and policy making across a range of spaces, from portfolio management to process evaluation to policy evaluation to outcome evaluation. I think when we all say responsible indicators here, we don't mean we should necessarily throw them all out. We need to use them at the right level and for the right purpose. Which we've shown a lot of these purposes across yesterday, right? Science mapping is a really important way to distill vast amounts of information down so that we can make responsible policies. We can also look at co-occurrence, which I think we started out yesterday talking about. How can we identify relationships in really large data sets? Again, at the right level of analysis, how can this be really important and valuable? We can also look at this in terms of national performances. We could take economic indicators and relate it to it to be able to make decisions about how disciplines emerge within countries and within their contexts. And of course, doing all of this responsibly. Now, it's an interesting point that I want to pull his attention is we often cite Goodhart's law and say when a measure becomes a target, it ceases to be a good measure. And we certainly see that in the proliferation of predatory journals. But what about open access and open science? We talked about that yesterday. Should it be a goal of the scientists to make their work open? Is making openness an indicator a good thing? Is it actually bad? Would that become a bad measure if it became a target? These are, I think, questionable things that we have to discuss when we are creating these different indicators. And of course, there's been much written on all of these things on how we should use science indicators and what are the best ways and to rank and think about all of those. But I'll sort of end with sort of three things for moving forward. I think that there's a lot we can do in exploiting the richness of bibliometric metadata to allow for further exploration of this system. Yesterday, we said, okay, there's only 5, maybe 6 variables that we can use. But I actually think that there's perhaps more variables that we can use and more variables that we could create on the data in order to expand what we're doing. Just looking at a Web of Science label, we have a lot of different things, right? We know about the people, we know about the topics, we know about institutions and countries, we know about their funding agencies. Combining those in new ways becomes really informative for telling us things like the mobility of scientists across the world, the funding of scientists across the world, how open all of these spaces are when we start to connect it with other data sets like UnPaywall. How are people contributing to science? As we start writing contributorship statements instead of just authorship statements, that becomes a new form of metadata that we can use. So I think there's a lot of way in which we can introduce new metadata on texts in order to be able to do a lot more socially responsible and interesting bibliometric work. So a lot of that requires then connecting it to new sources of data, to think about those new sources of data and how we pull them on. One of the things that we're doing is just trying to exploit full text data itself. Yesterday, people said, you know, citations are embedded in text. right? And there's texts all around those citations. Can't we know more about that? So looking at citation context allows us to really understand more about citations themselves, but also around scientific knowledge production. This is a work we did on disagreement in science, looking at how people introduce and disagree with an article within their own space. We also have policy documents that come into this that we can start to look at that science and society interrelationship. But in order to do that, we're going to have to create a collective infrastructure. If we're going to look at all of these spaces and we're going to look at them together and in large scale ways, we have to have that. Now, one is just trying to reduce the burden of curation across all of us. So we did a study looking at funding, which I've shown. And you're like, great, there's funding metadata in Web of Science. That's wonderful. Well, if you go into it, here's some different ways of saying it. NIH, National Institutes of Health, Cancer Institute, et cetera, multiple manifestations just to get the NIH. So let's have a fun test here. How many different strings do you think there are in the Web of Science for NIH? Just like throw out three numbers, like over under game.
35.
35 strings? 100? 200? How about 12,241? That's how many strings. That's how many strings Vincent and I had to curate to find each of the instantations of this, right? So we have to do this collective curation. It makes no sense for me to curate 12,000 different things and then to have you go curate your own and you curate your own, right? We need to make these things available in ways that we can start sharing this. Right, we have disambiguation algorithms for gender, for example, that can be shared widely so that other people can start doing these spaces. We also need to think about taking ownership of our own scientific products, right? We talked about this yesterday. There is enough money in the system to create a collective infrastructure. We're just giving it to the wrong players, right? If we take all of the money that's already in the system and use it more responsibly and wisely, we could create a collective infrastructure. And that infrastructure could also be much more inclusive. Right now for scientometrics, most of the macro level studies are done in 4 or 5 places in the world. Why? Because they have really well curated, beautiful Web of Science data sets. What we're trying to do now is take things like OpenAlex, connect them to Google BigQuery so that anyone, anywhere in the world can do the same level of bibliometric analyses and not have that be restricted to a few centers of powers within this space. Now, I'll just end on this. I think that infrastructures and data are only useful to the extent that they actually address our key goals and questions. So we can keep making new data sets and adding new metadata fields, but if we just do that in absence of any key motivating questions, I think that that is wasted effort and data in vain. What we need to think about is, what is our shared research agenda for the Metasciences? What do we collectively want to answer? And what kind of data do we need to do that? And can we create that collective infrastructure rather than letting our questions be guided by the organizations that are creating the metadata, which is effectively what we're doing right now. So with that, I'll end and thank you.
Thank you so much. This was inspiring and provoking. So we should devote some time to the Q&A. I guess something like 10 minutes or something. So you are supposed to come here, right? I go.
Okay. Cassidy, my name is Paul Wouters for the online audience. Otherwise, they don't know who's asking a question. Very exciting meta agenda for our field, I think. Also quite challenging, also for our current resources, I think. But okay, I've got a question about the future and 2 suggestions for complementary elements in your historical overview. Eve cited yesterday the beautiful book of Randall Collins, The History of Philosophy. And I think if you look at the sources in philosophy in China and India, you now only have a European perspective. They also discuss questions that come up later again in our own fields. So that might be useful as a suggestion. then I missed a pillar in the history, which is psychology of science.
Yeah.
Which is it's an older, so Maslow was Gregory Feist, were authors there in the past, but recently you see a kind of new interest in the psychological dimensions of doing science and scientific research, which also influences the way people behave, we ourselves behave, and the interaction with social structures is interesting. But sociology cannot only explain this, so I would really suggest add psychology of science. And then the point about the future, how do we tackle this pretty big set of agenda points that you raise? I think we also need mainstream computer scientists in order to both set up this collective infrastructure. We have beautiful examples in the Linux and Python communities, how to set up even partly funded by companies sometimes, publicly available and publicly managed resources on a very large scale. And if a couple of teenagers can pull this off with Python, then we should be able to pull it off from our relatively luxury university, well, not always luxury, university positions, not always luxury. It really depends on your job. But we do have resources that we can mobilize, and I completely agree with the atmosphere of your proposal. So I think we need also to think about making connections with these communities that are now not linked to us, but actually are also partly facing the same kind of technological and political challenges. Thank you.
Thank you, Paul. I mostly want to just thank you and give time for other questions, because I agree with you completely. I'm horrified by the Western-centric nature of this history, of my history and our history generally. I think we're not taking into account all of the contributions to the meta-sciences that are happening in non-English languages outside of Western countries. So I think we definitely need to build that up. The psychology of science is an interesting one. So I debated putting it in, but it seems to have disappeared or been renamed or relabeled. And so you saw a lot of it between like 1910 and 1925, and then it pretty much vanishes. And so is it now cognitive science? Do we need to think about what it looks like in that? Trying to understand where it fits, I think it is an interesting question there. And I agree with you. We need to have partnerships with CS and others. I think yesterday it was mentioned the great increase in hiring of an administrative layer at universities to do a lot of the ranking space as well. So when I think about this, it is labor intensive, but I don't know that it necessarily has to be the scientists. I think we already do have people who are laboring in scientific evaluation and assessment who could be brought into building this as well. I'll maybe stop there because I want to give time for other questions.
Yeah, I already have a list of 4. You 1, 2, 3, 4. So let's see.
And I can take all the questions first so everyone can speak, and then,
Okay.
then we can
Yeah,
go.
and mine will be quick, I hope. So you seem so optimistic. It's wonderful. You know, I witnessed this sort of quantitative turn in philosophy of science, and that's, I think, why Eugenio's organizing this conference. But and it's been happening in the last 10 or so years, maybe. But what I see amongst philosophers of science is they're reinventing scientometrics. It's terrible. I'm not sure we're great at it. I've been publishing in scientometrics, I think since 2003, but those papers are just disregarded by philosophers, like they're read by other people. So what do we do? I guess I think philosophers would be willing maybe to work with scientometricians, but the trouble is they might think, oh, I've got a problem. Now I'll put you to work.
No, it's a great point. And one of the things that I didn't show here because of time is we have done a mapping exercise of all of the sort of mapping all of the fields of the meta-sciences, and philosophy of science is sitting out on its own little island, not connecting to anything. So one is reading those works. You said, you know, philosophers don't read or reward it. We need to start reading each other's work. We need to start referencing each other's work. We need events like this to pull us together, which sounds like a very naive Pollyannish answer, but it's true. Part of it is just we need to do the work of scholars and read everything that is relevant to us and acknowledge that there are things that are relevant that we're not reading, citing, or engaging with, right? So there's a responsibility there that I think we all have to take.
So I'm gonna take one in two was.
Thank you very much for this inspiring overview. I would be curious to hear your thoughts, how to kind of bring the agenda from the ground using the educational kind of angle. Yeah, because what I also see is that the educational landscape becomes very scattered. Not only that we don't have light towers high enough in the scholarly world, it's also where those aspects are taught is almost unfindable in the curricula. So I would be curious to hear your thoughts on that.
Yeah, we don't have enough time for all my thoughts on that because I love it. Okay, so my one thought is this, is that the students do not see the demarcation of these spaces, right? So having taught in various summer schools or other things, the students aren't saying, oh, I'm a philosopher of science, I'm not going to read quantitative science. That's not happening, right? So in effect, they are coming in with a willingness, and our institutions, whether those are journals or educational institutions, are creating that demarcation itself. So I think that really it is in that space of education that we have the greatest opportunity to create this more interwoven future. And how we do that, I have lots of thoughts on, but I'll leave it to other questions.
Thank you very much. First, let me praise you, because if you asked me 1 hour ago if that's possible to cover so much ground in a single talk, I wouldn't believe it now. That was really a bird view or a dragon view, given your premise was amazing. That being said, if I may play the devil's advocate, devils being here philosophers, we might say that perhaps one question that was not mentioned in your questions, because there was a lot already, is that philosophers usually tend to consider our own, is the normative question,
Right.
that you seem to hold very dear, though, because, for instance, one may ask, of course, descriptively, skewness seems a rather diffuse property, but should it be?
Right.
And I can't understand, based on your agenda, who should answer this question among all the subfields. And I say that philosopher may do that, can do that, but they don't always do, because sometimes they take the existent as given and try to be explanatory or even apologetic, like, let me explain you why, given that there is skewedness, it's right there to be skewed. And that's a lot of philosophy of science doing this job, and I'm concerned about this. So first question is, who shall do the normative assessment? All of us together? And second, brief point, another thing that was missing, or maybe that I failed to notice, is who shall study the relationship between science and politics? Because I'm pretty much convinced, and it was a topic emerging from yesterday's discussion, especially when it comes to research evaluation, that one reason why politicians put up and top-down impose evaluation is to say, to show that they are whipping bad science, bad public administration, or to show off something which is not understandable within the scientific community itself, but must be understood in a political broader agenda. So who should understand these and maybe do lobbying with politics to stop whipping the wrong people, at least? Thank you.
I love that question. So you'll see that the other thing that I didn't put as a separate field was science of science policy, which is ironic given that that's the program that I funded at the NSF for 2 years. But the reason for that is precisely what you're saying, is I think that we are all collectively should be doing that science policy interfacing, because it requires all of us. It requires an economic perspective, a historical perspective, a sociological perspective, right? You need the descriptive and you need the normative. So I would love for philosophers of science to keep doing the normative space. Let's say you create a map of science. You see here, this is how capital is distributed across a nation or nations. Then we have a normative investigation of it. That should inform the science policy to be able to say, this is how we should be doing agenda setting and a portfolio building given this, right? We need to have that conversation informed by history, informed by sociology in that space. I don't think you can do responsible science policy with only a single metascience lens. It requires that intersection. And so that's what I'd like to see for all of that.
Okay.
Thanks, Cassidy. So There's another pillar, and I have to admit, even I don't pay much attention to this pillar, and that's the rhetoric of science. And I only became more aware of it because there's somebody in my department that's involved in this. So let me just read what it is, just because I'm not I'm not in the field. So the use of language, mathematics, visuals, and other symbol systems in science, techniques for effective scientific argumentation and persuasion, and how rhetoric shapes and influences scientific discourse and public perception. So my question is, and I'm thinking we're heading into the age of AI, and I'm wondering how that's going to shape rhetoric. And I mean, that's more of a futuristic question, but yeah.
No, I love it.
Yeah.
And those are two of my favorite bodies of work. So
Yeah.
on one hand, Hyland's work on scientific writing, I think, is a brilliant one. So how we compose science, how we talk about science, so the science communication bit isn't represented there. So I agree, it's a really important one. As we go into AI, we're going to have to understand it. But also semiotics is sort of the underlying basic framework for scientometrics. My favorite work of Paul's is his work on semiotics, of really trying to understand that and bring it together. I think we're not thinking about the symbolic logic in our field enough. I think that there's a lot to be said there, and particularly as we're moving into AI, that's going to be important. Again, that is a critical thing of connecting philosophy of science with scientometrics, is through that lens of semiotics. So,
Thank you.
Good, thank you so much. So there was maybe one or something, other questions, but I think it would be nice to have like half an hour left for the coffee break, because we need to.
coffee.
Too. And I'm sure the discussion will go on. So thanks so much.